functions, we talked about domains and ranges. And how do we know if something was a function or not?
If the domain does not repeat.
Right, the X didn't repeat, it was a function. We also talked about function notation a little bit yesterday. So now we're continuing with this, but we're going to focus on specifically just linear functions. So when we are dealing with equations of lines. So we know a linear function, y equals mx plus b. If you have function notation, the y would be replaced with a what? F of x. So we could see f of x equals mx plus b. What does m represent?
Slope.
Which is how steep the line is. B is the y-intercept. What is a y-intercept? Where it crosses the y-axis. Where it crosses the y-axis. Alright, so first we're going to focus on graphing them. You kind of are all grown up now, so I don't print graph paper for you. You have to draw your own grids on things. Test or quiz, I might be nice and put a grid on it for you, but I think we can do it. So if I asked you to graph this, f of x, which we said is the same as y, equals negative 3x plus 7. Does anybody want a ruler? You're welcome. All right, so how do we graph a line? Where do we begin?
Start off at like 0.7 on the y-axis.
We go up to 7. Okay, when you are drawing them on your own, try to space it somewhat evenly. So we go up 7, and then my slope is negative 3. So that means from there we go down 3, right 1. Or you could go up 3 and left 1. 2 points is really all you need, but you could get more if you just continue to follow your slope pattern. I don't really know, it just keeps going in both directions. Hopefully yours is a little bit straighter than mine. Okay. What's the domain? And the range? Domain, we know left to right, this line keeps going, so we'll hit everything eventually. Range, bottom to top, again, keeps going, we're going to hit everything eventually. Alright, you guys get a problem. So graph it, give me the domain and range. So intercept is 3. Slope is 2, so from there we go up 2 and over 1. So it looks like this. Domain. Range. Are those two okay? Alright. What if I told you to graph x equals 3? So it's not quite the same. There's no y in this at all. If you have x equals a number, what kind of line is that?
Vertical.
X equals number is vertical. Let's be a vertical line at -3. Domain. Yeah. I'm looking at my possible x values. As you go from left to right, the only thing we ever hit is -3. Since it's just a single value, we can't write that as an interval. So you could put it in the solution set if you wanted. -3 is the only x value. Range, what y values do we hit?
Negative and positive.
Alright. Last one. F of x equals -3. F of x is the same as, so it says y is -3. So if it's y equals a number, what kind of line is that?
Horizontal.
Mm-hmm. So horizontal line at -3. Domain, what x values do we hit? Range, what y's do we hit? Okay, so all lines have a domain range of -infinity to +infinity with the exception of horizontal or vertical lines. Alright. Are we okay with graphing these lines? So next thing we're going to talk about is slope. So we know slope is the steepness of a line. We can do that. We've been doing it on the graphs as rise over run. We can also do it from ordered pairs. So we know x1, y1 would be an ordered pair, x2, y2 would be an ordered pair. So it's changing y over changing. What's the slope of a vertical line? If you think back, look at our vertical line we graphed. If you took 2 points on that and you tried to rise over run, this goes up to over 0, and you can't have 0 on the bottom. So the slope of a vertical line is undefined. What about a horizontal?
0.
If you try to rise over run, we rise 0, we run 2, and 0 divided by 2 is 0. So that is something important to remember. Vertical line, slope is undefined. Horizontal, your slope is 0. When you're finding slope, does it matter which points on the line you choose? No, the steepness of the line is the same everywhere, so any 2 points, if you calculate the slope between them, you will get the same answer. So let's practice one. So if I wanted the slope between these 2 points, we said slope is change in y over change in x. So this is like our x sub 1 and our y sub 1, x sub 2 and y sub 2. So slope is y2 minus y1 over x2 minus x1. So we get negative 10 over 4. Typically we leave our slope in fraction form just for graphing purposes, but it does need to be in lowest terms. So this would reduce to negative 5 over 2. You guys do that one. Alright, so you guys dig it. That's 8 minus a over 5 minus negative 3. So 0 divided by 8 is 0. Alright, so I think you guys are remembering most of this stuff pretty well. When you have a point in the slope, that's all you really need to graph the line. So we were graphing them from the equation if it was y equals mx plus b form. But we don't technically have to have the full equation. If I asked you to graph a line through the point negative 2, negative 3 with a slope of 4/3. So how would I graph that?
Find the point negative 2, negative 3, and go up 4 over 3.
So we mark that, and then slope 4/3. So from there, we go up 4 over 3. What if I started asking you if these lines were increasing, decreasing, or constant? What does it mean if a line is increasing?
It has a positive slope.
Yeah, it's positive slope. It's going up from left to right. So increasing means it rises left to right. So that means a positive slope. Decreasing falls from left to right. That's a negative slope. And a constant. What's that mean? So what's the slope in that case?
0.
So 0 slope, horizontal line, that's constant. We didn't talk about the scenario when it's a vertical line. That's when the slope's undefined. But is that a function?
No.
No, it would fail the vertical line test. So we wouldn't have any increasing, decreasing, or constant there. We really only use these terms when we're talking about functions. Alright. So far, so good? Alright, I'm going to put one up here, and I want you to take a second and match each of these with the graph. So which one is y equals 2x plus 3?
C.
This is a positive slope, so the line should be increasing, y-intercept at positive 3, so that's C. Y equals negative 2x plus 3. Yep, decreasing line, but the y-intercept is still positive. Third one, negative 2x minus 3, so that would be B. Decreasing line,
No, it's also opposite.
y-intercept is negative. Alright. What about x and y intercepts? What is an x-intercept? What crosses x? crosses the x-axis. If what is true about every single point on the x-axis?
Y equals 0.
Mm-hmm. So to find those, what you're doing is plugging in a 0 for the y, and then solving for x. When you write them as an ordered pair, you'll have whatever number you get, comma, 0, because the y value is always 0. It seems like people always do fine with x and y intercepts when we're talking about lines, but when I start talking about other functions, they seem to forget what it is. Okay, x and y intercepts are not unique to lines. It's any graph. We could find where it crosses the x-axis or the y-axis. Okay, that's always true and found just by plugging in 0 for the opposite variable. All right, so a y-intercept then. And to find that, yeah. So it's just the opposite variable is 0. So let's try and see. When to find the intercepts, write the answer as an ordered pair. So how do we find the x-intercept? The y is 0. So we have negative 3x equals negative 8 divided by negative 3x is 8 over 3. If I want that as an ordered pair, what would I put? So y-intercept, plug in a 0 for the x. 5 by 4, and we get negative 2. So that ordered pair would be 0. You guys try one on your own. So the x-intercept, put in a 0 for your y. You have 4x equals 18, divide by 4. So you get 9 over 2. I asked for ordered pairs, so it would be 9 over 2, comma 0. Y-intercept, plug in 0 for your x, so we have negative 6y equals 18, divided by negative 6, so y is negative 3. Ordered pair would be 0, negative 3. So all that's good? Okay. I'm going to put a question up here, and I want you guys to see if you can answer everything about this. Here is the graph. I'm asking a bunch of questions about that graph. From this. Rise over run. You basically need to pick 2 points that you can tell exactly where they are. So I could say from here I go up 1 and backwards 3, so my slope is negative 1/3. It's a negative because my line's decreasing. Y-intercept is, what if I said I wanted an ordered pair? Okay, x-intercept is? So equation y equals mx plus b, so my m is -1/3 x plus b, which is -1, or you could have put f of x equals -1/3 x minus 1. Zeros, that's a term I haven't really used today. What is a zero?
Any intercepts within the x or y axis,
Actually, only the x. So it's basically saying, where is this function equal to 0? So it's where does it hit the x-axis? So it's an x-intercept. We don't use those as ordered pairs. We just give it the number, -3. Sometimes they're called solutions. So solutions, zeros, x-intercepts, all the same thing. Where does it hit the x-axis? Is that one okay? Almost done. I know I'm talking a lot today. Trade-off is I won't tomorrow, okay? In 2006, about 60 billion text messages were sent in the United States. During the next 6 years, text messaging increased on average by 407 billion messages per year. Find values for M and B so that y equals mx plus b models the number of text messages sent in billions x years after 2006. So we have to come up with an equation for this. We need to know M and B. B is the y-intercept. That's like our starting value. Okay, we're talking about the number of years after 2006. So our starting value would be how many messages were sent in 2006. And this says we're already going to use it in billions, so we can just do 60 here. So our slope, rise over run, that's how much it's changing each year. How do we know if it's positive or negative? Increasing would be positive. If it were decreasing each year, it would be negative. So my equation would be y equals 407x plus 60. B, I want to know, estimate the number of text messages sent in 2012. X is the number of years since 2006. So 2012 would be 6 years later. So we'll plug in that 6. And we get
a big number.
a big number. 2,502, except what was this already measured in?
Billions.
So yes, very big number. Yeah, you could rewrite it with zeros if you wanted. Is that one okay? Last slide. In 2001, DVD sales were 12.7 million. In 2006, sales were 19.8 million. Find the average rate of change. Hey, average rate of change, that's not a word that I really use today. What is average rate of change? Yeah, average rate of change is the same as slope. If we're going to find slope, what do we have to have? 2 points. All right. So the first one, in 2001, what were my sales?
12.7.
Second point would be what?
2006 and 19.8.
So slope. Y sub 2 minus y sub 1 over x sub 2 19.8 minus 12.7. 2006 minus 2001. So if we divide those, it's 71 over 50 in fraction form. Decimal, I think, is 1.42. So in this scenario, you would have to have units. So we need to know what this represents. So go back to your slope. We did that by y over x. My y values, 19.8, 12.7. What were those? And those were in million. 2006 and 2001, what are those? Yeah, I mean, you could say it would go up 71 million in 50 years, or we could say 1.42 million per year. So a couple different ways of writing it, depending on if you kept it in a fraction or a decimal.